today so that we can look at the answers, and then I will have a meeting with the student reps, and then we can discuss a little bit what we can improve. Perfect. Then on the group work, so I think the groups should be assigned next week, so this is nothing that we are doing. So I think the student admin office is doing this, and I think the plan was to inform you about your assigned groups next week. And if you want to prepare for the group work, then the best would be to go through all the Excel videos on It's Learning if you haven't done so. Because you saw that basically for every topic there are some Excel applications, sometimes more, sometimes less. And they were prepared by Cohen, who was teaching the class before, and the videos are just so great that I just took this because I think he's doing this really well. And of course it's really good to understand the concept and to see a little bit how some things are applied. But it's also really good to see how Excel can be used for these things, and in general how to use Excel. Because, I mean, probably you differ quite a lot in how much experience you have with Excel, but some things can just be a little bit annoying if you plot something and you want to switch to the axis, something like that, and these are all things that Cohen shows. So it's really good to understand both the content, but also to learn Excel a little bit more. So I would really encourage you to do these videos and to also replicate them in Excel. I mean, this is the nice thing about videos. You can just pause them, you can type it in an Excel, and then you can compare. So please do this. And then the last thing, next week there's again another session with the learning assistant. So it's on Wednesday, I think 2 o'clock. Please all go there. I think it's a really great offer. You can sit there, practice it, practice for the exam, work on the questions. You can work together with other students, and of course you can always ask your learning assistants, which is might be a little bit easier than asking me. Of course everyone is invited to ask me questions, but maybe it's a little bit easier to ask them, and this is exactly what they are for. Right? So please go to these sessions, work on the problems, ask them questions, and it's next week, Wednesday at 2. Alright, so let's practice a little bit the APT. So here we have an exercise that asks us to consider a 3-factor APT model. So these factors are given in the table. It's first a GDP factor, so what happens when there's a change in the GDP of a country. The second is related to energy prices, and the third to long-term interest rates. And then we're given the risk premiums for the different factors. We also know that the risk-free interest rate is 5.8%, and then we should calculate the returns on the following stocks. So the first stock is a stock who's uncorrelated with all 3 factors. The second one has an average exposure to each factor, so B is 1 for all the different factors. The third has a high exposure to energy, and the fourth has a negative exposure to energy prices and an average exposure to the other 2. So maybe let's say, I don't know, 4 or 5 minutes. Try to do this on your own. I mean, of course you can discuss with your neighbor, and then we can compare. And maybe I'll write this formula again. So return I is the risk-free rate plus these different factors. So in terms, RP stands for risk premium, factor 1.
Il y a un gars avec un mec dessus, un gars à sa droite, et c'est le gars à la droite du gars qui est à droite de Rennes. Ouais. Une fois, tu sais la learning qui est avec le student assistant. Ouais. J'avais fait l'exercice en anglais, savoir qui est. Parce que moi, je ne vais pas pouvoir venir la semaine prochaine aussi. Alors moi, la semaine prochaine, je ne suis pas là. Je m'oublie parce qu'il y a beaucoup qui est là. Donc, je ne serai pas seule. Je ne vais pas finir. Je peux moi. Je vais même rater mon truc. Voilà. Je prends un peu de retard. C'est ok, c'est pas grave. Je m'en déplaisir. Moi, c'est...
And of course, if you have questions on this, then feel free to ask.
Normalement, lundi, vous avez pris les billets d'avion. On fait billet de train et l'avion, je ne l'ai pas encore pris parce que je ne suis pas compris. Normalement, mercredi ou jeudi matin. soi-même, je vais passer un jour avec mon copain. C'est la machine 15 minutes. Ah, on va rester tous les deux. Ouais. Ils vont à Flamme. Alors, expensive. Risk-free interest. B1 c'est quoi B1, en gros B1 c'est genre à quel point ton stock est corrélé à ce facteur. Genre à quel point ce facteur a une influence sur ton stock. Je trouve ça bon. Il y a la 1 for each. Ça veut dire qu'ils sont tous corrélés à la même value. Ah là là, en gros juste tu mets genre un facteur devant chaque attribut lequel a l'obstacle. Et après aussi, c'est genre facteur B2.
Alright, I think the few of you are done, so maybe let's compare. So, where do we get the right formula for this? Is basically first question. And it's this one, right? It's the expected risk premium, which is given by the risk premiums of the different factors times the exposure to the factor. And here it's really nice because we are giving basically everything. We are given the risk-free rate, we are giving the risk premiums of the factors, and then for the different stocks we are given the sensitivities. Okay, so in principle we have to fill in this formula. So the return of a single stock is the risk-free rate times the different factor exposures times the risk premiums of the exposures. And the risk premiums is what's given here. So the risk premium on the first factor would be 5.8%. Okay. The risk premium on the second factor was 0.9%. And the risk premium on the third factor is 2.8%. Okay, and the risk-free rate was 5.8. Okay, so the first stock here we know that the stock is uncorrelated with all three factors. What does it mean? That means it performs independently of these factors. So all these exposures are equal to 0. So if all this is 0, then this is very simple. Then the return on this stock is just equal to the risk-free rate. Right? Because all these B's are 0. Okay. So for the second stock, we were given that the stock has an average exposure to each factor. Average exposure means that all the B's are equal to 1. So B1 is equal to B2 is equal to B3 is equal to 1. So we can plug in with 1 for all these B's. So the return on the stock is the risk rate times just the risk premiums, because the B's, the sensitivities or the exposure is 1. So plus 5.8, this is just the same, plus 0.9, plus 2.8%. And this is equal to 15.3%. Alright, for this third stock, we're given this as a pure play energy stock with high exposure to the energy factor. So B2 is equal to 2.2 and 0 exposure to the other two factors. So we know that B2 is equal to 2.2 and 1 and B3 are 0. So we just plug this in. So the return on the stock is equal to 5.8% plus 0 for the first factor plus 2.2 times 0.9% plus 0 is equal to 7.78%. And then we do the same for the fourth stock. Here we are given the context, an aluminium company stock with average sensitivity to changes in interest rates and GDP. So that means that B1 and B3 is equal to 1. So this is the same in the CAPM, by the way. So if you talk about average beta, that would be the market beta, which is also 1. And here we have a negative exposure of B2 equal to 1.7 to the energy price factor. So the aluminium company is energy intensive and suffers when energy prices rise. Okay, so let's plug this in. So we have our risk-free rate of 5.8%. Then we have 1 times the first risk premium, which was 5.8% again. Oh, no, then we have a minus 1.7, so this is the exposure to the second factor, times 0.9%. And then again we have 1 times 2.8%. This should be 12.87%. Alright, so I think the plugging in part is probably not the most difficult one. Of course, the most difficult one is to understand what is asked here, which formula we need to use. And here you have to be careful whether you are asked about the returns of a stock or the risk premium. So if you were asked about the risk premium, then you just put subtract the RF from the RI, or we don't put it here. I mean, the formula in the slides is given for the risk premium, which is just the return of the stock minus the risk-free rate. So you just have to be careful whether you're asked about the risk premium or the return. And the difference is just whether you add this risk-free rate or not. And then you just have to think about the formula, you have to think about which information are you given to know what the exposures are and what are the risk premiums. Alright. So, and with this, we are basically done with the second part, which was about risk and portfolio choice. But we won't start the third part today, we're going to start it next week. In the third part, we will again talk about cash flows a little bit more in more detail, because, of course, also coming up with cash flows in the future is not so easy. And then we will use the results from the CAPM with to really determine the cost of capital, which in the end we really need to determine the net present value. But today we practice a little bit what we have learned, because I know this is a lot, this is confusing for you, so I think it's good to leave a little bit time to practice. So is everyone done with writing? So. Alright. So let's start with this one. So I have prepared three exercises that can be done in pen and paper. And then a fourth that could also be done, but we're going to do it in Excel. Okay, so let's start with this one. Which of the following portfolios is inefficient and why? I hope you can read this up there. For you in the back, is it fine to read this? Okay, perfect. Thank you. All right, so again, maybe let's, hope this is not going to take too long, so let's take 2-3 minutes to think about this, discuss with the neighbors. So which of the portfolios are not efficient and why? And I hope you can read it. So on the y-axis we have returns, on the left, on the x-axis we have standard deviation.
En boîte à l'investissement, plus tu as des retours sur investissement. Et c'est vrai que 45, tu prends 20, c'est pareil. Pour 25, tu prends 15, pour 30, tu prends 17. C'est vraiment faible. C'est bien. Tout à l'heure, tu m'as parlé, j'avais la tête. Tu m'as dit que par rapport au tu avais fait le facteur directement sur le c'est un facteur de la globalité. Ok, mais ça va, je vais le faire. Mais il y a énormément de mais après, je sais pas si t'as vu, ils ont envoyé sur X-Learning, c'est en disant oui, c'est pas encore s'il y aura des formules ou pas, on a eu beaucoup de questions, on vous dira bientôt. Je comprends et je trouve ça logique parce que dans tous les jours à ton travail, ça fait culture surtout avec des petits, genre vraiment tout à l'heure.
All right, let's try this one. Perfect. So I guess we're done with that one. So which ones are inefficient? Does anyone want to answer? Would you have just talked? You were perfectly right. So maybe someone else. You can just guess something and tell me what you think. Yeah.
Well, I think for sure, E is worse than
Why?
because for the same level of standard deviation it has
Yeah.
and then similarly
Perfect. Yeah, perfect. Great. Perfect. So again, we want high returns, we want low risk. So we want to be basically somewhere here, right? On the upper left corner. So you have to think of all the different portfolios. Is there a portfolio that brings us closer there? And exactly as you argued. So if you look at the portfolio, look at the risk and the return, and then you think for a given level of risk, can I get a higher return? Or for a given level of return, can I get a higher risk? So can I somehow move up here or move to the left? Perfect, but you were perfectly right. So let's quickly write this down. So A, so just A, D, and G. So A, you would get a higher return with a lower standard deviation. So lower risk. If you invest in B. So I guess A is actually the worst. So what about D? Here, you exactly said it, there's just a portfolio with the same level of risk but a higher return. Yeah. So you could get higher return with the same level of risk if you invest in. By the way, if you can't read what I'm writing, always interrupt me. And then you also mentioned G over here, so you can basically get the same amount of return with a lower level of risk. Yeah, perfect. You could get the same return with a lower level of risk if you invest in F. Yeah. All right. Maybe let's move on. I will, of course, upload the solutions. So if you're not finished with writing, just check it out online. All right. So this is the next. Assume the risk rate is 4%. You have a financial advisor and must choose one of the funds below to recommend to your clients. Whichever fund you recommend, your clients will then provide them with the risk for borrowing and lending depending on their desired level of risk. Which fund would you recommend without knowing your client's risk preference? And then you're giving the three funds, A, B, C, and for each fund you're given the expected return and the volatility, which is the standard deviation. Okay, so maybe let's take 2 minutes to think about how you can answer this question and which is the best fund. Alright, so maybe let's discuss already. So does anyone have an idea how we can tackle this question? So which formula, which expression, which concept, or general, that's which idea we can use? Anyone? Okay, that's fine. I hope you're just too shy. Yeah. So in general, so the intuition behind this is perfectly right. So we have to think about volatility and the return. Of course, I mean, higher volatility might be good for someone who likes a lot of risk. But we also learn that there is a portfolio which is best for everyone. And then, since you are giving that you can remind it with the risk of borrowing and lending, then everyone chooses the perfect portfolio, and then if he or she wants to become more risky, you can just invest more in this portfolio. Either you put all your wealth in, or you even borrow to invest more in this portfolio. But it really, it's independent on the risk preferences, what is the best portfolio. Because we have this one expression that gives us the relation between expected returns and the volatility, and this is the Sharpe ratio. So we want the fund with the highest Sharpe ratio. So what is the Sharpe ratio? This is the expected return minus the risk-free rate. So this is the expected risk premium divided by the risk. So divided by the stock's standard deviation, which we can write. 8, right? I mean, here it's not stock, it's funds. So the expected risk premium of the fund divided by the standard deviation of the fund. And then we compare this for the 3 funds, and then we choose the fund with the highest Sharpe ratio. And the Sharpe ratio is a concept that is widely used. So if you want to do anything with finance, you should know what the Sharpe ratio is, because everyone is interested in the combination of expected returns and risk, and this is exactly what the Sharpe ratio tells us. This is the expression of the expected return, or expected risk premium, divided by the volatility. And of course, you want this to be high. You want a high return for a given level of risk. Or if you look at, we fix the expected risk premium, then we want a low risk. So we want this expression to be high. So when we look at fund A, we are given an expected return of 10. We know that the risk rate is 4, and we know that the volatility of A is 10. So we can just plug this in. 10% minus 4% divided by 10% is 60%. And then we do the same for B. For B, we are given 15 as expected return and a volatility of 22. So we have 15%, we subtract the risk-free rate, which is 4%, and then we had 22 as a standing deviation. And this is 50%. And then we do the same for C. For C, we are given expected return of 6 and a volatility of 2. So we have 6% minus 4% divided by 2% is equal to 100%. And then we compare this, and we see that for C, the Sharpe ratio is highest. So, of course, we pick C. And the idea, what you were mentioning, is very intuitive, because you could think if somebody wants to take on more risk, then this person could just invest in the fund with the highest volatility, which also gives us the highest return, so it should be good, right? But what's really important here is that since you're allowed to borrow and lend, you can just invest in the best portfolio. Everyone can invest in the best portfolio, and then your risk preference just determines how much you invest. So if you don't like risk, then you invest only a little bit in the optimal portfolio and the rest in the risk-free asset, basically leave it on your bank account. And if you're very risk-loving, then you invest everything in this portfolio or even more by borrowing. Right? So this is really important to understand. Because there is objectively the best portfolio, and this is the portfolio with the highest Sharpe ratio. Because it has the best relationship between expected returns and risk. So this is exactly this tangent portfolio, right? So if you think about this line, efficient frontier, it's more like a curve. And then you think about the line with the highest Sharpe ratio, with the highest slope, which just touches this efficient frontier. That gave us the tangent portfolio. The portfolio with the highest Sharpe ratio. Alright, so let's move on. 2 more exercises. So this is about the CAPM and how we can use it to calculate the net present value. So the Epsilon Corporation is evaluating an expansion of its business. The cash flow forecast for the projects are as follows. So in the year 0, basically now, we have to pay 190, maybe 190 million. And then in the years 1 to 10, we have a positive cash flow of 47 each year. And then we are given that the firm's existing assets have a beta of 2.3. The risk-free interest rate is 5%, and the expected return on the market portfolio is 11%. We should also assume that the project has the same systematic risk as the firm's existing assets. So what is the project's net present value? And again, maybe let's say 3 minutes to discuss this. And of course, if you have any questions, you can also raise your hand, also one over back in the back. I can come to you. All right, let's go.
En fait, je prends des notes depuis le début. Vraiment, ça me saoule. Ça va pour la prochaine fois. 1 to 10, 47, genre en 10 ans tu fais 47, c'est ça? Je pense, genre sur 10 années t'as 47, 40 je pense. C'est là, c'est ça. Ça me... je sais pas. Mais en fait, je sais pas, genre les boîtes, ça me dérange pas. Tant que genre les trucs pour ajouter un, bien sûr. Évidemment. Et genre, tu vois, il y a des... Je sais pas. Et je sais que parfois, par exemple, il est allé à un bar et il y a 3 filles qui sont venues le voir. Et il a voulu faire genre une phase de simulation, pas du tout. Et en fait, les meufs, elles ont commencé, je sais pas comment elles ont fait, ça m'a bien trouvé. Elles mangent pas bien. Non, ils n'acceptent pas. Mais en fait, il est en public, donc il les a pas non acceptés. Il les a pas refusés, genre. Et par exemple, il est en mode... Non, c'est là ce soir de la lui. Genre ça veut l'entendre. Non. Et moi, je suis grosse folle, genre en mode... je sais pas. Par exemple, genre c'est pour son pote, parce que du coup après ils se sont intéressés à son pote. Mais si elles organisent un truc et qu'il a invité, j'ai pas envie qu'il y aille.
So here you're given already a little bit more information, and the more information you're given, the more complicated it becomes. this, I understand that. So what are you asked? You asked about the project's net present value. And to calculate the net present value, we basically do two things. We need the cash flows and we need the discount rate. The cash flows here we are given, right? This is very simple. We have minus 190 and then we have 47 for years 1 to 10. So what's not so clear here is which discount rate to use. But this is exactly what we can use the CAPM for. So the CAPM gives us the required rate of return, which is basically our discount rate. So and then we just need the formula for the CAPM, which is the return of a stock or investment project or portfolio, whatever, is the risk-free rate times beta, plus beta times the market return minus the risk-free rate. And these things we are all given here, right? So we have the beta, we have the risk-free rate, and we have the expected return on the market portfolio. So then we just plug it in. Our risk-free rate was 5%, beta is 2.3, and then we have 11% as expected return on the market portfolio, and we again subtract the risk-free rate, which is 0.188 or 18.8%. And what's important here, we can use it as a discount rate because here it says assume the project has the same systematic risk as the firm's existing assets. Because we are giving that the beta for the firm's existing assets, right? And only since we can assume that the new investment project will have the same level of systematic risk, we can apply the same beta. This is very important here. But since this is the case, we can use this as our discount rate. And then you calculate the net present value. And here we actually here we have this overview of formulas, right? Because this is an annuity. Because we have this fixed horizon and we have the same cash flow as every year. So this is an annuity, and here this is the formula for the annuity, right? So we have to think about this formula and then plug in what's relevant here. So our net present value is the first cash flow of 190. We don't have to discount this because this is happening now in year 0. And then we have basically an annuity starting from year 1. Because from years 1 to 10, we have this constant cash flow of 47. So we have 47 times the formula for this annuity, which was 1 divided by the discount rate, which is 0.188, and then minus this larger expression, so 0.188 times 1.188 to the power of 10, because we have 10 years. And if you plug this in the calculator, then you get 15.35. So again, when you ask about net present value, you need the cash flows and then you need the discount rate. And the discount rate here comes from the CAPM because we can assume that the new project has the same level of systematic risk and we can use the same beta as for the firm's existing assets. So we can use this to calculate our discount rate. And then we have to think a little bit about the form of this cash flow stream. And since we have cash flows that are constant for fixed horizon or fixed period, and starting the next year, this is an annuity. Then we use the formula for an annuity and we plug in our discount rates and the cash flows, and then we arrive at the net present value. All right. So let's look at the last one. Alright, so let's do this together. There's a lot of text. I know, this is annoying, but this is basically what reality is, what most of your jobs are going to look like at the end. You're given a lot of information because reality is complex. You have a lot of information, and then you have to find out the relevant information that you need to answer the specific question. Alright, let's go through this together. Company Bell is a bicycle company that started its activity 3 years ago. Alex and Sarah are the owners of the company located in Oslo, near Majorstuen. They invested all their savings into this company and went to the bank to get a loan. Their shop is located in an old building which has been renovated. Because of their client-friendly approach and good service, clients like to come to their shop and ask for their advice. Things are going well and they want to open another shop in Sinsen. They need to invest in this new shop. First, the purchase price today of the space is 2 million. They will immediately start renovating the place, but they expect it to take about 2 years because it's really in a bad shape. This year they expect to spend an additional 1 million and next year 500,000. As they will provide the same quality of service, they expect the revenues will grow gradually from 60,000 in the first year to 120,000 in the seventh year. There will be an additional investment in the fifth year of 50,000 because they want to install solar panels. At the end of the seventh year, they are convinced that they could sell the store for 6 million kroner. What is the net present value, assuming that the cost of capital is 8%? So here, you are given the cost of capital, and you have to calculate the net present value looking at all these different pieces of information. So I will give you, no, actually we should compare. Alright, so, next this thing. Let's try Okay, let's do it like that. Of course, I mean, you could do this also pen and paper, but it's a little bit easier in Excel. So, first, let's think, so we have 7 years and we have different cash flows. This is always important if you get these types of problems to sort this a little bit, when are you getting which cash flow. So in the beginning, we have to pay 2 million to purchase this place. Then we also spend in the same year 1 million on renovation. Next year we spend 500,000 on renovation. Then from next year on, we already have some cash flows coming in. In the beginning it was 60,000 and then gradually it became 120,000, so each year it increases by 10,000. And then we also had another information, which was that in the fifth year they want to spend 50,000 on solar panels. And they are convinced, I mean this is a little bit simplified because you don't know really what happens in 7 years, but they're convinced that in 7 years they're going to be able to sell their shop for 6 million crowns. So we have different cash flows in time and you want to come up with the net present value because you want to decide whether it's a good idea to do this or not. You also give them the discount rate, the opportunity cost of capital. So what do you do? For each year you calculate the sum of the cash flow. So let's do this. So this is this one plus this plus all the possible cash flows that could come in at some point in time. So you do this for all the different periods, right? But we learned that there's the time value of money, which is really important to take into account. So of course we have to discount this. So every year we can calculate the present value. And for the present value, we take our cash flow here, we divide it by 1 plus the discount rate, which is 8%, and then to the power of our investment horizon, which is given up here. All right? And then, since this is the first year, it should be the same as the actual cash flow, which is, so it's 3 million. And then let us fix the opportunity cost of capital by using these dollar signs, because this is the same for every period. I'm done in 2 minutes. All right. Okay, then let's do this for every period. And you can sense check a little bit, because since we are discounting, it should be less than the actual. So let's pick the same format. So we can sense check whether the numbers are a little bit smaller than the actual cash flows, because since we're discounting, they should be smaller. And then to come up with our net present value, we just take the sum of all the different cash flows, discounted cash flows, which gives us this number here. All right. And you see this is a positive number. So the net present value is positive, so it means that it's a good idea to go ahead with this investment project. All right, and of course I will post these exercises and solutions online.